Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 65, maximum number of tasks you can assign. So I actually didn't solve this during even the virtual contest, as you can see here. I was missing a couple of things, and we'll talk about that in a sec. But yeah, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this farm. It's a very hard one, but we can discuss it in Discord or wherever you like. But yeah, so this one, I think it's just kind of this one's very hard for me anyway, because there are a couple of layers of greedy, and I was kind of I think the way that I described it was that I had kind of like I think the two layers of greediness, and I think I was just tweaking my knobs in that, I was like, oh, maybe I could be greedy here. Didn't work. Okay, and I turn it back, and then I turn this knob and I go, okay, I could be greedy here. Nope, and then I turn it back. But if I did both at the same time, it would have worked. But I was missing that trick. And I think we'll talk about it in a sec. And you could watch me solve it live next, but though it's a long video, so maybe and a lot of it I don't do much, but if you are going to watch on a faster speed, and then maybe in the middle I don't do much, so skip toward the end where I actually read people's code and try to understand people's code from first principles, and then see where that works. But I was just missing an observation. I think I knew what I wanted as an observation, but I think I miss, like I said, there are two levels of greediness, and I think I was trying out how to be greedy on one dimension or the other dimension, but not both at the same time, and that kind of was why I wasn't able to get it. And yeah, it's kind of, I don't know, it's kind of interesting in that way, because if you actually look at the video, if you kind of look at the video of me live, you'll see that I actually have all the pieces at different parts, but I think I was missing that one thing where I had to put it together. Yeah. Anyway, so this is a binary search problem. Even knowing that, I wasn't able to come up with it. So the binary search that you ask yourself should be, okay, can I do X tasks? And this is the question that I actually didn't get, like I said, but no spoilers, please. But basically, let's say we're the greedy thing is that, can we do X tasks? And if the answer is yes, using P pills, right? If the answer is yes, then try X plus 1. If the answer is no, then try X minus 1, right? Kind of. I mean, this is binary search, so you would actually, keep on doing that. But then the question is, how do you, and the problem that I was trying to figure out was, how do you figure this out optimally, right? Because for me, and that's kind of that's one of the things that I struggle with, is kind of figure out how to prove greedy solutions. And even though I was kind of thinking along these lines at a certain point, I wasn't able to kind of think, okay. I wasn't able to think greedy in the subcomponents, or at least I wasn't able to prove myself enough to kind of explore a little bit more. Maybe if I did, that would be a lot easier, but that was not the case. But anyway, so the key observation that I was also kind of dancing around but did not come to, at least not explicitly in a way that I was very clear about, because I think if I was clear about, then I could explore it more. But I think it was in the back of my mind, I wasn't able to kind of lift it to the surface level. And the way that you do that is, well, it's kind of make one observation, and this observation is this: if we can do X tasks, if we can do any X tasks, then we can do the smallest or the weakest, smallest X tasks. So this is the observation that I'm talking about, is that because I think so for me anyway, and I talk a lot about how I solve it because I don't want to look, if you're looking for an explanation video, like I'm sure that there are a lot of different explanation videos that just tells you the answer, right? For me, the interesting part isn't the answer, it's about how to get there and how to maybe connect those dots. And for me, I'm going to tell you how I connect, or how I try to, or how I will try to connect these dots in the future. So take it as you will. If this is not interest of you, then maybe my video isn't for you anyway. But yeah, the way that we can think about it is, okay, let's say we can do any tasks, right? Let's say, we have 9, 9, 8, 5, 5. We sort them in descending order, and we sort the workers in descending order, right? So the idea is, and I kind of was playing around with this, but not explicitly, which is why I didn't get it. Yeah, which is unfortunate. But if we can do any X tasks, like let's say we can do 998, right? If we're able to do 998, then that means that, I don't know, there's some number X, 9 plus, what does that mean, right? We can do this, right? If we can do 998 and we have 3 workers, that means that we have some numbers that represent this for any number A, B, and C. But that means that if this is the case, and for sake of visualization, we'll just put A, B, and C as 0. So if this is the case, that means that after sorting, we can shift this to the right with and it will have 3 answers at every time, right? And because of this property that but the inverse is not true, right? Meaning if you have 855, you cannot go left and hope that it matches. And this was the thing that I spent too much time on, was that I was trying to match this way and then kind of shift to the left, right? But because of that, then you can ask yourself, and let's say there are no strength pills, right? But because of this, we can just arbitrarily take the last X elements, right? So that's basically part of the binary search, right? But then now you say, how do we get strength pills, right? Well, the idea turns out to be greedy as well. So this is what I mean by 2 levels of greediness. So let's actually use this thing again. So 66421. I mean, there's one additional observation that I put in code, but actually doesn't matter, which is that you always want the strongest X elements as well to match up if you're gonna do this alignment thing. But actually that doesn't turn out to be matter, because if you can use numbers that are in here, that means you're not using a bigger number, which doesn't make any sense anyway. So it doesn't really matter, or like it doesn't improve on the answer because you have to do it that way, right? But yeah, so okay, so then that means that, yeah, but so that means that now, another way of thinking about it is, and we can get rid of this, and we only consider the suffix. That means that we ask ourselves, we have to. So now this question becomes, because before, if you kind of do, I think, so the thing that I was struggling with, and I was trying to figure out an algorithm to kind of match them one at a time, and maybe shifting this 4 to 8 and so forth, and I was struggling with that a lot. And you can see in the video and fast forward to it, per se. But the way that we ask ourselves if we can do X and making this observation, what we end up doing in the effect is that we throw away these numbers, and then we ask ourselves, we change this end question to, okay, if we have the X smallest tasks, can we do them all, right? And then now this is a question that you can do in a way that is greedy as well. Because before the 9 and the other 9, just given this question, it's not immediately clear that the greedy solution works, right? because then maybe there's different ways of kind of matching these or whatever. But if we change this to a can we do them or question, well, what happens, right? What happens is that now we have a binary question. So the thing that I was struggling with was that I was like, okay, given a greedy solution, how many tasks can we do? But of course, that's not a binary answer, and therefore there's some decisions to be made. But here we have this question, then we have a binary question where, if you think about it as true and false, you have you have some true, because if you think about it, and the way that I try to think about it is just saying things out loud. Is okay, if I have one task, can I do them more? Yes. If I have two tasks, can I do them more? Yes. Right. And then you go, okay, if I have 10 tasks, can I do them more? No. Right. So we have a false. If 10 is false, then we know that 11 cannot be true. And if 8 is true, we know that 7 has to be true, right? And so forth, ... So that means that there is some boundary between true and false, and we're trying to discover them, right? So that's basically the idea behind this binary search part, right? And then the question is, okay, given X tasks, can we do them all using all these workers? And the idea here is also just greedy, right? So and this is the part that I miss as well. So I miss greedy in two dimensions, and he's not thinking about it in these ways, to be honest. And the way that I think about it is, okay, let's say we have to finish all of these. That means that we always have to match an 8. There's no decision. We have to do it, right? And this was the part that I struggled with, because during the contest, I was like, okay, maybe the 8 can match a 6, but then if I matches a 6 and use the pill here, how do we sure that these doesn't mix? Is there a way that I could do this and then move the 4 up, etc., right? But what if I use the 4 pill here? What if there's a later answer? And then, I don't know. There was a lot of decisions here that I just couldn't figure out how to resolve using a heuristic, right? But if you have to, then you go, okay, this is an 8, right? So there are only two things you can do. One is not use a pill. If this was 8 or bigger, if this was 8, we go, okay, then we're done, because we don't have to use a pill and we get rid of it. But if we have to use a pill because the biggest number doesn't match, like we don't have any worker that can go pillness, right? We have to use a pill on any worker. Well, then it becomes, okay, which worker do we want to use? Well, in this case, you would not use the number 6 because, well, I mean, you can, and that would work, but it is not an optimal answer in the way that, you can, if you use a smaller number, then it's always optimal in that, in what I call the swap argument, or I think there's a thing called the exchange argument, right? So we can reduce this problem to a slightly easier problem as an example, which is that, okay, the exchange argument is basically that right now, if we use the pill on 6, we will get the answer 1. If we use the pill on 4, on the smaller number, we will, at worst, let's say this is a 2, right? If we use the pill on a smaller number, we also get, we get a worse, maybe that's a bad way of saying it. But let's say this is an 8 and this satisfies this 8. If we move this to the front by using a pill, this will always yield an answer that is at least as good or better, right? Meaning that, if this is a 7 later on, and we use this pill, we still have the same same answer of 1, right? So this is the swap argument that I would make, and from that, you can do it one at a time. So this 8, we get rid of the 4. The 5, we could just use the biggest, and so forth. And then once you do that, this is basically it. This is the problem. And we'll go over the complexity in a second, but we'll go over the code with it first. So yeah. So this is the binary search that we asked about. MIT is the can we solve the easiest mid tasks? Yeah, so actually I wrote this here, so maybe I don't need to write this. So yeah, so given mid easiest tasks, and this is actually not necessary, I would use a cross, like a strike through necessary. It turns out that this is not necessary, but I thought that this was necessary when I was writing the solution, but it actually turns out not, right? And see if we can use them more. So here we can actually just replace this with this, and it'll be okay. Though it's a little bit slower, but it's not a big deal because the binary search is a little bit slower. But yeah. So let's keep this here for now. So this is a little bit more efficient, but not even the way that I wrote it, to be honest, because I make a copy here, right? But anyway, but pretending that we don't need to make a copy and we just use indexes. So yeah, so this is going to take. Oh no, it started raining. Or hailing even. Coming down heavy. Sorry, friends. But yeah, so this is going to be log of let's say min of t and n. Yeah, because you can only do at most n tasks anyway, right? Or at most t or the min of t or n task. So this is this many iterations, and then here for the greedy algorithm, this is no longer true. I mean this is still true, but we can. It is true about that precondition, so we don't need this anymore. But the idea is that okay, so we in Python we use a sorted list. In other languages you may use this a multi-set or some kind of tree data structure. But yeah, but basically, and yeah. So for each task and we have to do all of them as we said, and this is already keep in mind that we sort it in descending order. So okay, if we can not use a pill, we have this thing where okay, if the strongest person is, and this is the task that is the heaviest task, right? Meaning that everything in the future is going to require something less. So therefore, we just take the strongest person because like it is almost the inverse exchange argument of okay, if the strongest person does a weaker task in the future, that can only lead to a worse scenario. So yeah, so we move the biggest remove the biggest worker, and also the task goes on, and then we continue without using a pill. Otherwise, if we ran out of pills, then we return false because we just don't have any more pills. But if we can use a pill, then we use a pill. We do a binary search on the remaining workers of strength of at least task minus strength. Of course, this is just the worker plus strength is greater than task. This is the inverse of that. If this is the case, meaning that there's no worker that exists, so we return false. I don't know if you can hear it. Wow, this is hailing. So it is not raining, it is literally hailing like ice. So I'm glad I'm not outside. It's actually 61 degrees outside and it's hailing. So it's actually crazy. Okay, I know that I'm recording these live. I just hope that you cannot hear it over the mic, but it's actually hailing in here and it's crazy. It doesn't happen that much because it's actually 61 degrees Fahrenheit, which is, I don't know, like 15 degrees Celsius or something like that, and it's hailing, so not great. Anyway, yeah, so if no worker exists, let me also annotate this. No workers is strong enough, even with pill, then we return false, right? Otherwise, we just remove the worker from the working list, and that's pretty much it. If we can safely remove all the workers, then all the tasks, or not all the workers, but if we can safely remove all the tasks and have a worker that match that task, then that means that this is possible, and that's pretty much it. So the question is, can So if you watch me, so let me actually go over this for a second. So this loop is obviously O of t, and each of these loop will have a pop or remove, which is O of log n. So this loop will take O of t log n time, and that is, of course, and we also sort the workers, which is plus n log n, roughly speaking, because technically this can be min of t and n, but we'll just leave it like this because it's easier to understand. And so this is a loop of greedy. So here, let's just put this real quick. And I'm not going over the binary search here that in depth. I have a lot of binary search videos. Check those out. But yeah, so this is this per iteration. So in total, this is just this thing times t log n plus n log n. And in theory, not the way that I implement it, but the way that you can implement it if you optimize for it. You can also do this. But yeah. So this is the time. For space, we just have linear space, right? Because we don't really use anything else. I mean, I know that sort list is a little bit nuanced, but for the most part. Cool. Yeah, so that's all I have about the analysis and the explanation. Let me know what you think. So one more thing I would say is that I get this question a lot where people ask me, how long do you spend before looking at the answer or taking a peek at a hint? I actually try to avoid spoilers, and I try to avoid all hints as long as I can, because I'm maybe arrogant. I think I could solve it. This is where I would say having a buddy maybe helps a little bit, or the Discord channel helps a little bit in that you can ask, is this solvable given what I know, right? Because I think there are some problems in which like you cannot solve it without knowing a certain things, knowing a certain trivia. Like if you don't know Floyd Warshaw, for example, or something like that, it's very hard to solve a problem that requires it, right? Or if you don't know like Manager's algorithm or something like that, I don't know. Right? There's some algorithm named after a famous computer scientist, and you're not realistically coming it up with in even days, right? Not usually anyway. In theory. So in that case, getting a hint or even knowing whether you need a hint is a good thing. So that's why I suggest either buddy system or the Discord. And yeah, and for me, I don't know. And one thing I would say is that, and I hope this doesn't come off as a humble brag, but I know a lot of algorithms. I know a lot of things. I have a lot of things in my toolkit. So for me, I don't spend as long. I mean, it depends on my feeling about it. Like if I have a good feeling about that I'm on the right track, and on Code Force especially, and so on Leetcode, I do expect myself to have the trivia to solve every problem. So I will spend a very long time before kind of giving up, if you will, or at least getting a hint. On Code Force, it's a little bit more nuanced because on the tougher things, there are also like a lot of mathematical properties that I might not spring. And when I'm younger, or when I was younger, I actually would spend days on a problem. Now well, one thing is that I'm not trying to be as good as I need to, or I'm not trying to be the best anymore, to be frank. Like I'm still trying to learn. I'm trying to see interesting things, but that my priority is not to optimize for my rating or to learn everything or to be able to solve everything, right? Like I'm at a level that I'm comfortable with, and that's okay. But you might not be at the level that you're comfortable with respect to that, right? So I would recommend just spending as long as possible. For me, for this particular problem, I did give up a little bit. Looking at the answer, I do kind of wish I spent more time trying to figure it out. I think I had all the pieces, I just didn't put them together. And I kind of was a little bit sad about that, afterwards. Because after I think after one hint of this thing, I was able to solve the other parts. Though it might have taken longer if I didn't have those hints. So I think I could have gotten it. So I should have spent more time there, but I don't know. The video may have been really long, but it may have been interesting. I don't know. So that's what I would say. But yeah. Anyway, that's all I have for this one. So I think the tricky part as well is that there are two parts of greedy, and there's a lot of proof. And for me, just proving them independently, like I was trying to do this without this observation, and that kind of cost me a little bit. But this one I would have gotten next, but I think, and if you watch me during contest, I think I made one mistake of I was trying to get this effectively a variation of this function to return a number instead of a binary true false type thing. I think if I was able to kind of but some of this is just putting together, right? Because I wasn't able to come up with this because I was missing this. But as soon as I made this observation, I was able to come up with this greedy pretty quickly. So I don't know. Maybe it's a chicken and egg, and that's what made this problem hard. I don't have this up, but not many people solve this problem, right? So don't feel that bad, if you will. Even though the components are not hard per se, but even like Alex, whom I respect a lot, with respect to these problems, like even he took like I don't think it took an hour. I think, but he took like 50 minutes on this one, which is a long time for him because of how much I respect him, right? But anyway, that's all I have for this one. Yeah, you could watch me solve it live in the contest next. Q4. All right. How we doing on time? Because I start off time. I don't know. Okay, so I have an hour and 7 minutes left. People already finished, of course. But it looks like I would have been doing pretty good time. Maybe, depending on how good you ask. Okay. Like I'm top 50 maybe. Okay. Focus. You have and task and workers. Okay. Okay, let me read. I'm reading it too fast, and yeah, I don't know if this is a problem people run into, but reading it too fast. So you have the strength of each worker is stored in workers. Okay. So you have task, which are requirements, and workers. Okay, each single task must have a strength greater than or equal to. Okay. You have pills. Okay, magic pills. Okay, so up to this point, it may be some sort of bipartite matching, maybe, but okay, let's see. However, you may only give each worker at most one magic pill. Pill. Okay, so pills is a constant. Only give each. Do we have a limit number of them? Pills, magic. Oh, by strength. Okay, strength is the constant. Pills is the number. Okay. So it is something. It feels like some sort of bipartite matching type thing, but with a curve. Yeah, I mean, this can't be max flow, right? What is n? Let's take a look. Okay, at least n and elms makes it seem like it should not be max flow. Yeah, because that's too big. But I mean, it probably is max flowable to be honest. But I don't. But that's not the intended solution anyway. I mean, any n squared dp or nm dp is too slow as well. If I had to guess, there's some kind of sorting, and then maximum task that can be done. If we sort, can we do some dp from then? Or some kind of two-pointer maybe? DP may still be too slow in that case. I mean, we definitely want to sort it. It doesn't make sense to not sort. So let's do that. Because there's no ordering, doesn't really matter. And then I wonder if you can do something like, does this always give the optimal pairing if we just I feel something better is that someone got in 7 minutes. Nowhere is good. But um, can we do DP on the delta? Well, you can't do it on M anyway, so, or pills rather. So that still doesn't make sense. Maybe some sort of binary search. No, that doesn't make sense to binary search it, because in that case you just do greedy, right? I feel like I have a greedy solution, but I can't prove it. And some of this is maybe a little bit meta. Is that if it was greedy, you'd think people would solve it already? Oh, wow, second, nice, Josh. But anyway, wasn't looking at it yet. But okay, how do I even prove this to myself? Oh, and actually, I think I just assumed that N and M is the same. So because they're not the same, that matching is a little bit awkward. Okay, so I think if N and M is the same, then maybe greedy would work. But actually, I missed this, which is that they're not. So that means we have to think about it a little bit more, if nothing else. Because okay, so that's where the difficulty comes from. Because I was trying to think why the greedy doesn't work if N and M is the same thing. But now we have some sort of thing. Can we do greedy? Well, the strength pill. Okay, but okay, I'm thinking sorted, but what if we sort it backwards? Does that help? So we have these tasks. Can we do greedy sorted backwards? Because if we can use a worker, we should, right? And we always use the strongest worker. Well, the question is, if there's a misalignment, then you end up running out of pills at some point. So that's the problem with greedy. If this where you can just align it by not doing the first task. If you don't do the first task and everything aligns, then that's the case that greedy fails. Don't really have a good idea about this one, to be frank. But yeah, can we do DP on whether this particular one should be solved? Is there a cascading effect? I don't know. I don't think so. I think there's subproblems that the subproblems are quadratic, or n times m anyway. And we want to do something in n squared time, or n log n time maybe. Well, it's already n log n, so I guess there's no linear. And I don't think you could do this without sorting, so that's probably the lower bound. And it's not something with the numbers here. Yeah, because I was looking at this example and I think greedy would work only because n and m is the same. But if it's not, then don't really have a good idea. Just thinking. Can we do something with binary search? Do we always want to use a pill? No, because of the misalignment that we set. Because, for example, we have one pill and you have something like this. But if it was 444, refresh to kind of get a sense of, because other people have starting to finish. Wow, much slower. We don't have any idea on this one. Or my standard tool is a little bit off. The pills are the decision. If there were no pills, how would I do it? If there are no pills, then we can just walk the thing. I think that's okay. So yeah, if there are no pills, then greedy works by sorting. If there are pills, then we can. What does being pills mean? So that means that, okay, so we have some alignment that doesn't have pills, some sort of matching in a greedy way without pills first, and then having pills, what does that enable us to do? That enable us to do we shift away? Does that make sense? Is that a thing that happens? How do we know if we want to be able to shift in an optimal way? It's okay, so let's say we have some greedy matching without pills. How do we figure out how to improve on that answer using pills? So that is our minimal answer, or that's the answer that is the minimal maximal, and then we want to improve on it using pills. We have extra workers. So let's say we have a greedy alignment. What does that mean? That means that one person gets to shift. So okay, so giving a pill will, but then how do we figure out which worker to shift using these pills? Okay, let's use some pencil and paper. let's say we have something like this. About pills. Okay. And it will always look something like that, I suppose. And then adding pills. Adding pills is kind of like swapping. How do you do the math on that swap? So for and how do you do that in non-linear time? Then there's two so okay, so you have this disalignment from greedy solution, and you want to make one of them use a pill. If this person uses a pill, then it can move a little bit to the left. Maybe I'm thinking backwards. So what happens if for every where we do greedy the other way? What does that look like? We do greedy the other way. Yeah, I don't know. I feel like I don't really have that many ways of solving this, but I feel like I'm missing a property that I'm thinking about. So one pill. Let's see. So let's say without pills, then this 10 matches this 10, right? And this 10 matches this one now, but everything shifted kind of. I'll mute this a bit. Yeah, I guess it's muted. I'm really stuck, to be honest. Can I think about these as segments? No, I don't know if that helps. How much time do I have left? I don't even have an idea, to be honest, which is the hard part. Okay, I have 57 minutes left for this one. Let's see if I could come up with a visualization a little bit. I think we want, so now, I mean, I think for n as you go to m, the greedy works. And in this one, you might match the 10 with the 15, but so without using any pills, match the 10 with the 10. Okay, so I guess my question is, does using a pill, okay, I think I have some ideas about I think the decision that I try to think about is this thing about if we use a pill, how does it affect us in the future? And I think there is some way of making it local in that it doesn't that much, or some sort of greedy maybe, but I can't really or I don't have any ways that are proven anyway, or that I can prove. Let's see. Story, yeah. So for example, the 15, how do we represent this, right? Because, okay, so let's say our example is 10, 15, and then 10, 10. Maybe is 10, 10 a good one? I don't know. 5. How do we decide to match this way and not this way? And how do we keep it from moving in the future? So we do greedy. We have some answer X, and then given pills, we can at most improve the answer by pills. So the answer is between that greedy solution and that greedy solution plus pills. That helps. Can I do something with the deltas? And I think there's some like not transitive things, right? For example, if strength is 5, and in this case this matches up, but this is 9. But if we match the 10 and the 10 in a greedy way, then this doesn't match, right? So we have to, and let's say pills is equal to 2. So we have to match the 15 and 10. So we have to use the pill. So how do I determine that we have to use both pills in this case? Right? The 5 doesn't even matter, I guess. And on the flip side, okay, so let's say we just greedily use both pills. What does that mean? If we greedily use both pills and we don't have pills later on, can that mess us up? Where using one pill would be a better? I guess maybe not. I don't know. I assume that you can. Okay. I mean, I think I've been thinking about this edge case for a long time. So what I'm going to do is kind of just do the greedy and then see if I have a an example instead of keeping coming up example, then lead to 5-minute penalty. So let's I don't know if this is the best move per se, but I'm also like running out of ideas. We've been sitting around for like, I don't know, 10-15 minutes, something like that, doing nothing. So let's give it some try. Oops. If workers I is greater than task. Otherwise, if workers I is greater than string and pose is greater than 0. Okay, right. 2132. Oh, did I even get this one wrong? Whoops. How did I get this one wrong? Let's see. 3 and 3. 3 matches 2. And then 0 plus 1. Huh. Why did I get this wrong? Oh, whoops. Maybe. I think we just. That's still a little bit awkward though, but okay, 3122, so I messed up this one. Okay, so it seems like greedy already doesn't work for the last case, maybe, because we gave the we gave the pill to the first. What? Yeah, I think we gave the pill to. Let's see, gave the pill to one of these, and then 8. And that's pretty much all she wrote. 8, there's no match. 5, there's no match. Oh no, 5, there is a match. So there's only 1 5 for match. So you have to give the pill to 4. So we can't do the greedy. Okay, so greedy doesn't work just by this alone. I didn't really look at this case too closely, apparently. So, okay, well that's good. We didn't even have to use 5 minutes for it. Okay, so given this case, we want to use this. Wait, what? Did I put workers first? Workers and then tasks. So yeah, we use this one, and then the 6 6 matches to 5 5. Okay. Can we do greedy in well? No, because if oh, we have to think about how to do greedy in a smart way. In that, if we greedily try to figure out the 9, then we'll. I mean, I guess the 4 can. Wait, what's the strength again on this one? Yeah, I mean, we can do the 4 and the 9, I guess, but. And I guess that doesn't matter. Actually, I think in this case, the example is misleading, and that not misleading, but you would always actually just choose the 9 instead of. So okay, so maybe that makes sense. Okay, so here you would choose the small. Would you choose the smallest thing though? Or the one that gives the more, because that at most shifts that up that way. But like, can that affect anything later? I guess not, because this is basically. I think maybe that is the missing key that my drawing was, because I was trying to think. I was trying to think without leapfrogging, but maybe I can leapfrog using pills. But what if this was 11, right? If this was 11, then we would greedily choose the 6 using that one pill. And then we still have leave with 2, even though the 4 should match with an 8, right? The question is, okay, what if I'm trying to think, maybe is there a property where we okay, so let's say we have this thing, right? This array. Maybe we get to use this in some way, so I don't want to delete it yet. Okay, so let's say we have this array, and then we can add 5 to, okay, in this case there's only one pill, so we get either or which obviously is the same, or 9 is 2 1, or which is for workers equals to 3, this is already suboptimal, right? Oh, sorry, for tasks is equal to 3, this is already suboptimal. Well, in this case, it doesn't. Well, this one doesn't change the answer, and this one doesn't change the answer. This one actually may still. This one still changed the answer possibly. So, yeah, maybe. I don't know. And then the other one is just 666. Okay. What if we use greedy, but we binary search on what is the starting point of these pills to kind of basically shift them to the left? Does that even make sense? I don't know. Okay. I mean, I'm thinking definitely there is some bias toward proving but we only have 36 minutes, so it's as good as any, I guess. Let's give it a spin. I don't know if this is right. This is gonna be n log n, something like that. Okay, let's give it a spin. How do I want to think about coding this? I guess I don't need. I think this is okay. And we need to get rid of this. This is. That means that. Oh, I guess we needed to sort this then. Okay, fine. And then is equal to. Okay, fine. I guess this could be min or something. I always get off by 1 on these, so I'm just. Is this worth doing it this way though? Let's see. is 0 pills, then okay, so this was 1, okay. I've been getting these indexes wrong, so I'm trying to think. Oh, we're inclusive, okay. So. This will give me how many used. So we want to maximize this formula, right? Maybe I did this a little bit wrong. Let's see. I mean, we could use ternary search. That's always fun. I think there's a way to kind of figure that out, but I'm a little bit weird. So it gives us an answer for this, but we don't have. Oh, maybe I didn't. I thought maybe I could do something like this, but this just gives me a number. I mean, I know that. Okay, fine. Maybe this is right. Could be wrong. If this is the case, what happens? That means that the answer is not on the right, so yeah, I'm gonna have some rounding type things. And do some little bit of a cheating. Is this even right? I don't know. Yeah, I might have a. Oh, that's not what I thought it would happen. Also, we do this, which is very, very bad. We want to two, so I'm still wrong on this one. Am I? Did I mess up the indexes? So I think I need to reverse them. So I reverse them, and then we want to on a third one. Maybe I'm just really wrong on this one. Oh, I don't know how to do it. I'm playing around with different things, but and I haven't done discrete ternary search in a while, but Should have done it this way, actually. Okay, still gives me the wrong answer, unfortunately. Why is that though? But if I change the 4 to a 5, why does that not work? Something's wrong with the coding in general, I think. Because if we change the 2, oh, what the? Wow. Like really bad at coding. Okay, fine. Okay, still wrong, but maybe slightly better in that. Why does this get printed twice? I print twice. Oh, because it goes this and then it does this max thing. Okay, fine. I think I'm changing the array a little bit. Am I being sloppy? Oh, I forgot to change the current. Okay. Okay, now this is too much of a 3, 2, 3, 4. Wow, how am I off by that much? Okay. What is this answer? Let's see. Sometimes you just have to grind it out, but I don't know if I have any answer for this one. So this is the case. Okay, so this seems right. Well, this clearly seems wrong. Why for a second time? This should not be. From the third index. What is going on? Why is this so weird? Like, okay. So this matches 3, but this matches 4. Why does it matches 4? Because somehow this array is not, you go to this plus whatever. Why isn't it? Dun dun dun. Because we just wanted to put 2, we want to put it on 6. Or on 4, so that's 9. Do I have an off by 1? Is that why? So we add, okay, I do have an off by 1. That is why. Okay, 3, 2, 3, 3. Is that the right answer? Nope. I mean, I fixed that one at least, but I'm getting the other ones wrong. Okay. 3, 2, 3, 3. So the number 2 is wrong. Why did I get 2? So I have 0, 0, 0. 5, 5, 0. Why does this return 2? 5, 0, 0. Oh, because we already used the pill, so this doesn't make sense. That's what happens when you copy and paste. Okay. 3, 1, 2, 2. Okay, so that makes sense, or at least that is the right answer for this one. Is it too slow? I don't know. I think I'm just going to YOLO this a little bit because we only have 25 minutes left anyway. So, yeah. I have a print statement here somewhere. Okay. 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 So we have a wrong answer. Unfortunately, this wrong answer is going to be hard to debug. I guess this makes sense that this is the wrong answer because I think, I mean, I was a little bit trying to figure out as well whether this is the case, but you can imagine you have 2 separate chunks and you want to shift you want to swap some of them in the middle. Can I generalize that in a better way than me essentially doing brute force? But well, ternary search, but and this greedy, I need to be able to separate them from two chunks that I can do the same greedy on. I think that's the problem, is that we have multiple chunks. Okay, I mean, I don't know if I'm gonna solve this one. um, so you do get numbers that jump ahead. So basically this, but for example, if you do the same thing. So the reason why my thing is wrong is we do the same thing, but then you add, I don't know, 1,000 to each number and then duplicate the array. That would give us the wrong answer, I think. Well, I guess there's no way for me to kind of debug this, but yeah, I think that is definitely a wrong answer. Now that I think about it a little bit, because basically you have this, but then now you make it 2 pairs, you duplicate this array, and you duplicate this array, and then say you add 1,000. Basically, you're doing 2 independent answers, or 2 independent problems in the same problem, and my answer, I mean, the expected answer should be 6, but I suspect I give a 5. Okay, I give a 7. That's actually ridiculous. But maybe I have some typo. Oh no, oh yeah, actually, because these are able to solve these ones, that's probably why. But there's something like that that is giving me the wrong answer. And to be honest, the problem is that it's not even, I don't even have a great idea on how to solve this. Because if I did, then I can work until after the contest to kind of keep going. But I feel like I tried a lot of stuff for 20 minutes left. But so greedy can greedy work? The DP is actually pretty easy, but okay, so I guess the problem that I'm still trying to solve is please. Come on, man. Maybe I've gotten it so far. Really have no idea on this one, but though a lot of people are getting it, but some in very long time, given some, I mean, the top scores. So, put no spoilers. I mean, do I really have to be explicit every time? Okay. Yeah, the problem is that let's say we have something like this, and strength is equal to 5. We do greedy. This is actually. Well, I mean, we did greedy, and greedy doesn't work for this one. So, um, hmm. Anyway, so again, we have 9, 5. Okay, so we do want to increase to 4. I don't know. Okay, sorry, getting a little bit distracted. So we want to promote the 4, but how do we figure out 4 is the thing to promote? Let's just say the 2. Can I think about it in a reverse way? Well, I mean, if we do greedy, we're going to have disalignment, right? But let's say, for example, we have, this is a 6, right? We would still have the same alignment, but we would use this here. So let's say we keep having numbers. I guess the question is also does it ever make sense to take a number that's used? I guess not, because if a number is used, then okay, so let's say we do greedy another way. I mean, right now we've just been doing sweeping left and right, but let's say we do. To be honest, this problem's a little bit ruined for me because of the hints. This is what happens when you do it on Twitch, I guess. I always said, but because now I can't even think about the wrong answer in a good way because some of the exploration is on the wrong answer, but I don't know. So let's say we have this stuff, right? So the 5, but how do we use the 5? I guess that's the question, because you can also say that on the same logic. I had some logic about matching the 5 with something, greedily matching the 5 with something, but then you can also say that for 8, for like, why don't we match it with 8? And I don't know that I can make that decision in a good time. So how do we get a case to isolate on the 4? About 14 minutes left. I spent like 20 minutes doing nothing, to be frank. Still don't have a good idea on this one. How many people solved it so far? I mean, a good amount of people. I mean, yeah, good amount of people, but not like a crazy amount. So I mean, this is definitely a hard problem. I don't know. Um, hmm. Hmm. Really have no idea. Did I miss something? No, I don't think I missed anything. This is pretty straightforward, and I don't think the problem is hidden in the constraint this time. Maybe I'm wrong. Um, the graph is too expensive to build explicitly, so I don't think it's a graph problem. At least not in a direct way. How do I align this one? So you move the 4 to the 8. Yeah, the problem is that I have some ideas about getting this span, because you can imagine you have this and changing this to this, which is what I did, but then now it extends further on the second pill, right? So what I did kind of works for one pill. So I think I have a one pill solution, kind of, but maybe not even, to be honest. Maybe I'm wrong on this one, but hmm. Don't really have any idea, to be frank. But I'm not ready to give up yet, because I still have at least 12 minutes. I don't know. Hopefully, people cannot hear the car alarm. It is, I don't know. There's a car alarm outside my window. I could hear it, and it's very distracting. And it's very annoying. And now I'm just doing the classic thing of procrastinating by talking and pretending that I'm streaming and whatever. But okay, focus lie. I definitely thought about binary search. I just don't know how to apply it here. What are other dimensions that we can abuse? Because I think the not alignment stuff is interesting. Don't really have a great answer for this one. Maybe I just don't know this one, to be frank. And it's something that I'll smack my head as soon as I see someone else do it. Usually pretty okay at these. What does taking a pill mean? And the other thing is that I think I treat them independently, but as this case, maybe not this case, but as this case shows, they're not actually that independent. So maybe I'm thinking about it a little bit incorrectly. Because there are pockets. I thought there may be pockets of. I mean, can you add stuff in a contiguous way? Okay, let's play around with. I don't even know if the delta array makes any sense because it's about alignment more than. Because if m is equal to n, then it is a little bit easier. Then okay, this is -3, -3, -4, -3, -4, right? That doesn't. This does not convey that there could be 3 answers, right? Okay, let's say we greedily match these. So I don't think that that's, just match them without pills. What happens? Then you have this thing. But this is the part of the exploration that I'm missing out because someone hinted that this was binary search, which means that this doesn't make I'm going down the wrong approach, which I know, but I would have explored that part a little bit more to kind of see where that goes. But now, given maybe as a incorrect hint though, but I didn't really dig deep into it. But this is why spoilers kind of messes with you up a little bit. I try to avoid it by doing the actual contest during the contest instead of on stream. But this is why sometimes you can have nice things. Okay, so I mean this. I don't know. I don't think I know how to solve this one. At least, I mean, can I think about it in terms of maximum bipartite arching and then the graph? What is the if I think about it in bipartite matching, then that means that, what does that mean? That means that we're adding edges based on strength, and for each thing that it doesn't fit, we can, I don't know, how do we choose between using these? Yeah, I don't know. Usually I have some idea that I'm working toward to play around, but now I honestly don't even have an idea to play around with, and there's only 6 minutes left in the virtual contest. This is kind of a sad moment for me, because you should have an idea to play. I don't even have any, I'm not even trying anything right now because I don't really have a direction about it. Yeah, I just really don't really have an idea. So I've been sitting here for an hour doing nothing. Not gonna lie, even knowing that this is binary search, I still don't have any idea. I think there's a property that I'm missing, or observation that I'm missing. I mean, okay, so I did make the observation about crossover and everything is over. But how do we know to start it from there and not say here? And also in this case, I think this is the part that messes me up a little bit, knowing the spoiler, is that I would kind of explore this, but now knowing that it's binary search, I'm missing some weird thing. Well, I mean, that's the fun part about doing these watching this live is that you get to watch Larry do nothing for an hour sometimes. Hopefully, it's very rare, but still, from time to time, this will happen, and it makes me sad too. So, not just you at home. Hmm. And I think this is one of those things where I don't even think I can think my way out. This is not me. Um, like sometimes you're on some thread that you can play around and kind of see how it shapes out, but I don't think in this particular case, um, I have. I don't even have an approach. Mm, I mean, I did a little bit, but I think that was just really wrong. Unless I have some implementation detail that was wrong. I don't think so. Hmm. Like, why was I wrong for this case? Well, it's hard to say. Except that I'm expected to match more. 35 pills is a lot of pills. Yeah, I don't think there's anything about constraints that I'm missing. And clearly, there is like a easy solution because people got it in 7 minutes. Hmm. Well, I mean, I shouldn't say people because these are the top people in the world. So maybe that's just me being unfair to myself as well, a little bit. But hmm, uh, hmm, yikes. Have I been thinking about this all wrong? Do I need to not sort? What if I sort not reverse? Does that help? Does that change anything? I just assumed. I think that makes sense from intuition slash past experience. But what if I sort it the other way? Does this make it easier? Hmm. Can there be a cascading effect? Hmm. Yeah, really no idea. I guess I think what I'm going to do is do a code review. Oh, I should take a screenshot of this because this goes away, I think. I'm going yeah, I think I'm going to just read other people's code and then see if I can understand it that way. We have about 20 seconds left, and then maybe I'll type it afterwards. Didn't really get this one. I guess I missed up on something. Don't know why I don't know why Q2 took 16 minutes actually, to be honest. Because I don't think my code is that bad. Did I? Let's see. I mean, I know that I had a wrong answer, but maybe I took too long to debug. Oh, I hope this doesn't talk me in some way. Okay. Oh, it doesn't. I wanted to the per minute type answer submission time so that I can because I forget what my first, when I guess I have it on video, so wanted to see what my first submission time is. But okay, so the contest is over. I'm 74th or so. I think what was I at? Like, was that like 27 minutes with a penalty? So that means that would have placed me. Ooh, yikes! I guess it's pretty good that I didn't do this contest then. But it would have placed me about 167th. Because I guess there are a lot of Chinese server people. But okay, so what I'm going to do now, because I really don't have any idea, and I think just to kind of go over some few things is that definitely keep trying. I mean, what I want to say, and I don't know if this comes off poorly, is that I have a lot of experience, right? So if I don't know something, and at least on a level that I know that I need to know, like I will look at the answer. But I think like when you're starting out, I do not recommend this per se, and that I think you should explore things a little bit. I think one thing that you can do, and because I have a Discord channel, it makes it easier, which I didn't have when I was younger, is kind of ask for a direction. In that, because for some problems you might not, like it might require an algorithm that you just never heard of, so there's no way you could have come up with it, or at least not with a reasonable amount of time. But there are also other type of problems where, like maybe just sorting in a weird way, right? And you can come up with it, you just have to keep on figuring it out, right? For me, because I know I have a lot of tools under my belt, and if I don't know it, then it may be some observation that I'm missing, and I'm trying to figure out how to learn. So okay, so that said, let's kind of learn together, and or you could watch me learn and kind of see if I just looking at solutions, how to figure it out, and that's how I usually do it. I know that there's a discussion forum type thing, but I save that for a little bit later maybe. Okay, let's take a look. Okay, so this is obvious. Okay. I mean, okay, so there's a binary search. Don't know if you hear the fire hydrant. Okay, so what does this actually means? This is kind of what I was doing, but I don't think I'm doing it quite right. Okay, so oh geez, sorry friends. There's a police thing, I guess, right outside. It's not even, I mean, I'm actually like about 15 feet from the window. No, way more. Maybe like 25 feet from the window. But this is New York. This is part of living in New York. Though for the most part, as you know, it's pretty good because otherwise you'll see it on stream all the time. But still, okay. Let's actually focus on to see what this does. So this is the mid. We look at the cheapest X tasks. What do we do about the cheapest X tasks? We put them in a thing. Okay, let's look at another one real quick because I guess they do the same thing. But why is this? Oh, this is just a multi-set. Well, this is just a. I was actually thinking about something similar for with sorted list, but I feel like I'm still missing something. Okay, so we start from the middle. I guess I did sort it the wrong way then. Didn't I do this? I did something like this, but I didn't do the binary search one. I think I did this, but with greedy, which I guess is wrong. But I'm still missing something obvious, or like I'm missing the observation. I don't know if it's obvious, but I'm missing an observation that leads to this. This is one of those things where the code might not tell me what is necessary because there is something more abstract about it. Let's kind of take a look at another code. Okay, this is not great code per se. Okay, binary search. Okay, let's see if there's anyone with cleaner code. Um, uh, hide this stuff. Sorry, friends. I guess if you could hear the siren, at least we know that my mic is doing very well because I know that people complain about it not being loud enough in the past. Um, but oh, that's true. I don't. I mean, I can. So someone in my chat is suggesting that um, I read Discord, which is probably a good idea. But I'm trying to figure out how to put it on stream in a good way. Um, hmm. Okay, I don't know. I scrolled down a few, and I don't know. I don't know. I don't know any. Let's see. Okay, well, this has a comment, which is, I guess, might as well as read the description at this time. I mean, I think also all these code roughly looks the same, to be honest. So I think I'm just missing the idea. Okay, so what is middle? Check repeat. Take min. So basically, oh, is that? I mean, that's basically. I mean, I had something. I mean, I wouldn't say that close, but I had that sort of an idea. But okay. So why is that the mid? That is the mid on a binary search because given the min. Oh, I see. So this is just saying given this alignment, does everything always match up? I guess so. Huh. But I was doing it one item at a time. Why is this necessary? Maybe I'm missing something. I mean, I feel like all the code's gonna look the same at this point. I just am trying to figure out how to understand this in a way. So one thing that I would say is that I'm not just learning this per se. I am trying to or I'm not just like trying to figure out the answer. I'm trying to also understand it in a way that it can be repeated in the future, right? That's part of the learning, and sometimes it is going to be slow, like what I'm doing now. But yeah, okay. What is P again? P is this is a little bit. Is this awkward? I don't know. What is the P bias? P is the oh, P is the number of pills, not okay. So that makes sense actually. For a second I confused pills with strength. Okay. So we basically just use this alignment, right? So we binary search on the alignment and then do greedy on the matching. And the matching is that it has to be a perfect match, or not a perfect match, but has to match everything. And this is actually what I said at the beginning of the problem is that if m is equal to n, then greedy works, right? So then now we're constructing a case where that is the case, where we binary search on the greedy suffix of, in a greedy way, because of the greedy, you can choose a suffix and then the prefix, and then we should be able to just match one, but yeah, we should be able to just match that way. So we get the biggest element, yeah, otherwise Otherwise, we search for the smallest element to remove it. Okay, I actually was doing my greedy a different way. I think that's the part that I'm missing from this. So I actually I missed two observations. To be honest, I think I know how to solve this now. Okay, let me try to let me try to think about this in a way of kind of re-understanding it. But okay. Let me see if I can think about this a little bit. Maybe I'll just do the explanation on the explanation video. But basically, okay. Okay. We if m is equal to n, we can greedily see if we can use all of I guess this is t in the way that I wrote it. Use all of the or we can use all of the workers with all the tasks, and we can do this in a greedy way, right? So this is greedy if yeah, if we have a workers and tasks, then in this case, and let's say if they're equal to each other in size, then if they're equal to each other in size, then we yeah, actually I guess in this case we have a sorted list. So okay, and then now we have tasks. Okay, so and we had something like this actually. For task and tax, if the biggest element is greater or equal to task, then this is I don't know. Then we can contain you actually, I guess. Oh well, we have to remove it, but dot pop. I think that's a thing. I could be wrong on that one actually. I think that's a function sorted list. I could be wrong. I could just remove the last element, but else, I think this is the part. This is the two observations that I missed. The first one is a little bit tricky, but this one I actually should have been a little bit better on. But I didn't know that was necessary. And this is the one that where the first time I implemented, if you go back, is that I just take the next number and then I add the strength to it. But now I can actually, I should take the smallest worker or the weakest worker that can after strength go. So basically this is task, we minus okay. Okay, if p is greater than 0, okay, wait, how do I want to say it? Okay, if p is equal to 0, then we're done. This is false because we cannot use any strength. Otherwise, task minus strength. Okay, let's just write pills is equal to p. So we want to binary search for this in sorted list. We want to get a number that's bigger than this. So okay, so index is equal to current.bisect left or bigger. So yeah, so if index is greater than length of current, we return false. Otherwise, current is it? I forget how the syntax about sorted list, to be honest, but something like this should be okay, I think. And then just return true otherwise, right? Something like this. Yeah, and then here, okay, assert length of task. Let's go to length of workers. And then here, in a greedy way, we always. This is the part that I did not get, and I don't know if I mean, I think I've seen. I've definitely seen it before, but it's not something that is maybe I think about enough. Yeah, right is equal to maybe min of tn, and then -1 for, because this is inclusive. Is equal to left plus right. And the part that I did not get is that we want to take, so the 2 levels of greediness. I think that's why maybe I'm a little bit bad, but we want to take the smallest or the easiest mid tasks and the strongest, I don't know why I put this in quotes, strongest workers. Yeah. I think that's also a remove though, right? Let me look it up. Sorry, give me a second. I don't like to remove it by index in that way. That's why. Though maybe I should have done that. Yeah, I remove and then pop. Okay, I think I'm good on the API here. Anyway, and then strongest workers, and see if we can use them all. Okay, and then if greedy, if we can greedy, so we want to take the last last mid elements, and then the first mid element. Maybe I'm off by 1. I'm always a little bit off by 1 here sometimes. So if this is good, we want to try something bigger. So left is equal to mid. If this is not good, we want to try something smaller, and mid is not good. Okay. Whew. Okay, I mean, I'm wrong here, but that's fine. So let me put this in here. Maybe I'm off by something. How do I have a Dong dong dong. Okay. Yeah, I think this is okay. Yeah. Oh, whoops. This should be equal to. I think I messed that up. Okay. So at least it doesn't go out of bounds, but still a little wrong. Dong dong dong. A little bit wrong because this should be inclusive. Okay. Whoops. Okay. So a little bit better, but not on this. Because why is this 5? Dong dong dong. Tell me why. Pills is equal to 0 if we cannot bind. Huh. Let's see. So this is marked as doable. Oh, it's because I didn't use a pill. Whoops. Whoopsie daisies. Silly mistakes. Okay, so that looks good now. Okay, let's give it a submit. Funny thing is, I had all the components in my head, and I even mentioned them. I think this is why I just wasn't able to put it together. This is why, like, I don't know. Could I have figured this out eventually without kind of peeping? I think it's tricky, right? Because I had all the tools for sure, But I think this part I wasn't sure that I needed to be even more. I guess this. I mean, so this greedy part. I think I should have been able to figure this out. In the sense that, but I don't. In the sense that it is clearly more optimal than the way that I was writing it. But I think they're like, it's like I had to be greedy in 2 dimensions, and I didn't really think about, and I was thinking about one at a time. Like it's like almost like we're twisting 2 knobs, and I was twisting one at a time, and then I reset it, and then twist the other one a little bit, and then reset it. And what I had to do was do them both at the same time, and I really was kind of, I don't know, just wasn't able to get there. And this is actually a thing that comes up very rarely, but I have seen it before. So it's something that I just really have been out of shape with practice and kind of be able to think about it. But yeah. Okay. I mean, I don't know what to say about this one. Yeah, thanks everybody for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, other contest problems from this contest, other contests. Just come to Discord, show your code, read some code. A lot of smarty pants in there. So yeah, come check us out. I'll see you later. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.